Good morning, everyone. So, as you know, we already have hot water for our showering system. If you don't know how it works, you can check our Ventool videos. And we needed some solution as well in the kitchen for washing the dishes in hot water. So finally I came up with a very space efficient solution. It's an instant water heater. I ordered it from AliExpress. It's XYFG brand, and I thought that we already have a 3000 watts inverter and we have a lot of solar power. So for a few minutes washing the dishes sessions, it is good for us. I installed it, but we have a little problem that this is not a 3000 watts, it is a 3500 watts water heater.
I measured its actual performance and it seems that incorrect data was listed on AliExpress. The problem is that our inverter can only continuously supply 3000 watts, so we will need to come up with some kind of workaround.
So we will get this water heater to run with only 3000 watts, so our inverter can withstand this power draw. So I bought a PWM controller with adjustable power regulation.
PWM control triac is a device used to regulate the power delivered to an AC load, such as a motor, light or heating element. A triac is a semiconductor device that can switch and control AC power. When controlled by PWM signal, the triac can be used to modulate the average power delivered to the load by turning on and off during specific parts of the AC cycle. So this will be the resulting signal. The PWM signal is typically used in conjunction with zero cross detection to delay the triggering of the triac in each AC cycle. This is called phase angle control. The later in the cycle the triac is triggered, the less power goes to the load. By adjusting the pulse width of the PWM signal in relation to the AC waveform, the triac conducts for a shorter or longer portion of each cycle, thus controlling the effective voltage and power.
Okay, so let's open it. We have a very big heat sink on it and the cable to the power regulator unit, and with this controller we can regulate the power, I think, in percentage. So we need to disassemble this water heater in order to connect the PWM module to the unit.
Here are the parts of the water heater.
I bought some electrical boxes, so I will paste this PWM controller to this box.
Many hours later.
Okay, so now it's half done. I have connected all the wires in this water heater, cut out some rectangle for this. This will goes to the top of the box. It needs to be waterproof, so I sealed the gaps with some leftover polyurethane glue.
One eternity later.
Okay, the final solution is ready for install. I have this power regulation box, this PWM box and the water heater itself. So let's install it. Okay, I just connected it for the tests. There is the water heater, but there is one little problem with it. I can show you. The issue lies in the fact that there are actually many different types of PWM control. There's forward phase control, reverse phase control, and some methods that switch the output on and off more frequently than the AC cycle itself. Some of these introduce only a small amount of noise and spikes into the system, while others introduce a lot. Inverters can tolerate a certain amount of spiking and noise, but it seems like the method used by my PWM controller isn't well tolerated. Unfortunately, I can't measure exactly what type of PWM this device uses because I don't have an oscilloscope. I actually anticipated running into a problem like this since there aren't many complete PWM controllers readily available that are designed for high continuous loads, and even among the ones I found, it wasn't clearly specified what type of PWM control they use, so in that sense it was a bit of a gamble. That said, I do have a few options. I could build my own PWM controller, but I don't really want to spend that much time on it. Another option is to buy a variac, which would allow me to reduce the voltage and thereby reduce power consumption. However, those things are incredibly large and heavy, not suitable for a camper van. A further option is to buy a 5000 watts inverter, but those are also huge and heavy and they cost about 20 times more than this water heater. I've thought one of more simple option. I could get another water heater, remove the electronics from it and keep just the heating element with the casing. Then I'd wire the two heating elements in series. That way the combined power draw would definitely be lower than 3000 watts. The new water heater has arrived, so I started taking things apart and putting together the final version. Let's see how it goes.
Let's see.
Well, it looks like this version works. According to the Victron Smart Shunt current meter, it's drawing around 2200 watts. So I'll count that as a success. It's important to note that this won't make the water hot, but in winter it will bring it to a tolerable temperature and keep your hands from freezing.
If you are interested in our adventures or technical aspects of building a camper van, don't forget to subscribe to our channel, and you can also find us on Instagram too. So thanks for watching, bye!